Hello everyone. Today we will discuss about structural isomerism. Before going to the details of the structural isomerism, I just want to say why there is a need for uh, understanding the concept of isomerism and what is isomerism. So simply, isomerism is a concept wherein two molecules have different, same molecular formula, but different arrangement of the atoms or the groups. So simply isomers are the molecules with same molecular formula, but different arrangement of atoms or groups. So for example, if you see a molecule which is having a molecular formula of C2H6O. So this is a molecular formula for a compound. And this molecule, for example, can be written as CH3, CH2OH, CH3, O, CH3. This molecule is contain two carbon atoms, ethyl alcohol, whereas this molecule is dimethyl ether. If you compare these two molecules, they have the, say for example, the ethyl alcohol molecule, it has two carbon atoms, one oxygen atom, and 3, 2 plus 1, 6 hydrogen atoms. Similarly, if you take the dimethyl ether, it contains two carbon atoms, one oxygen atom, and 6 hydrogen atoms. So both these are having the same molecular formula, but there is difference in the arrangement of the atoms of the groups. Here, if you see, you have two methyl groups, and in this case, you have an ethyl group and a hydroxy group, and here a ether linkage. So why it is, this is the basic idea of isomerism. Why it is essential for us to understand isomerism, because due to change in the structural features of these two compounds, both these are having different properties. Say, for example, the ethyl alcohol molecule is physically, it is liquid, whereas dimethyl ether, it is a gas. So whenever you compare two molecules which are having slight different structural features, they have different physico-chemical properties. As they have different physico-chemical properties, automatically they have different biological activities. So always the biological activity of molecules will depends upon the physico-chemical properties of this molecule. And not only that, not only ethyl alcohol is a liquid, and ethyl alcohol molecule, it is also having antiseptic property. Is also having the antiseptic property. Whereas dimethyl ether, it is generally used as an general anesthetic. So right here. It is used as a general anesthetic. So simple point is that always you remember a basic logic in medicinal chemistry that the molecules which have ethereal linkage, they are used as anesthetic. Ethers are generally having general anesthetic property where they can depress the CNS. So the point is clear. Just because of change in the structural feature, there is alteration in the physico-chemical properties, as well as the biological properties. So for example, in chemical point of view, ethyl alcohol is slightly acidic as well as basic, whereas the dimethyl ether is a neutral compound compared to this, right? So the chemical property is different, physical property is different, and biological property is different. Due to this particular change, we need to understand how isomerism is affecting. Not only that, not only in the terms of biological way or the medicinal way, the change in the structure is also having influence in terms of material science also. That is why it is very much essential for us to understand the arrangement of the atoms or the groups in a given molecule and how that particular arrangement is influencing the properties of that particular molecule. That is why it is important for us to understand isomerism. In this video, we are much focused upon one type of isomerism, that is nothing but structural isomerism. Okay, just a second. This right. So coming to the different types of structural isomers, the first and foremost type of structural isomers are the chain isomers or the chain isomerism. Chain isomers will call they have same molecular formula, because isomers have the same molecular formula, always it is the same. And in chain isomers, they have different simply alkyl chains, right? They have different alkyl chains. For example, if you take this molecule, this molecule is called as 4-carbon containing compound, which is nothing but N-butane. Whereas similarly, which has, if you see here, the number of carbon atoms is 4, and 3 plus 2, 5, 5 plus 5, 10. It has the molecular formula is C4H10. If you take another molecule like this, so 1, 2, 3, and this molecule is known as 2-methyl. At the second position, you see a methyl group, and this is the propyl chain, 2-methyl propane. If you compare these two molecules, again, it has 1, 2, 3, 4 carbon atoms, right? 3, 3, 3, 9 plus 10. Here in both these cases, the molecular formula is same. But if you see here, you have a 4-carbon chain. But in this case, you have, two types of chain. One is the propyl chain, the 3-carbon chain, and this one is the methyl chain. That is why the name methyl propane. So the molecules which have different alkyl chains, in this case, one butyl chain is there, whereas in this case, you see one methyl and one propyl chain. Such type of isomers are generally called as chain isomers, right? Generally, the chain isomerism is exhibited by the alkanes, right? As well as the substituted alkynes also, which contain a longest chain. They will also exhibit the chain isomerism, right? And the next type of isomerism is, we'll go on with the next type of isomerism. Right. The next type of isomerism is functional group isomerism, or simply it is also called as functional isomerism. So here it is simple. Already we have explored the what we say structures previously, and the functional group isomers have generally they have the same molecular formula. Then only we'll call it as isomers. Different functional groups. Previously we have seen one example, that is C2H6O. And for C2H6O, we have written two different molecules. That is, this is ethyl alcohol or the ethanol, and this is dimethyl ether, right? So here the point is it has a functional group. The molecular formula is same, but here you have an alcoholic OH, whereas this linkage is an ether, right? That is why they have the same molecular formula. That's why they are isomers, but they have different functional groups. Such type of isomers are called as functional group isomers, and it is also called as functional group isomerism or the functional isomerism, right? I hope it is clear. And we also have another type of isomerism known as what you say, the third one, positional or the regioisomerism. It's called as the positional or the regioisomerism. So the positional or the regioisomerism is they have the same molecular formula, and they have same functional groups, but at different regions or positions. That is why it is called as positional or the regioisomerism, right? So here the simple, if you take one molecule like propanol, 1, 2, 3. This molecule is called as 1-propanol, because at the first position there is, or the first region, you have a hydroxy group. Similarly, CH3, CH4, this molecule, if you see, this is 1, this is the longest possible chain. At the second position, you have the hydroxy group. That is why this is called as 2-propanol or propane 2-ol, and this is, or it is also called as propane 1-ol, right? So this is 1-propanol. If you see, they have the same functional group known as the hydroxy group or the alcoholic OH, but the position is different, or the region is different. That's why it is called as positional isomerism or the regioisomerism, right? We'll also explore one more example for this. This molecule here, if you see, 1, 2, sorry. Whereas the hydroxy groups are on the 1 and 2 positions, it is called as catechol. And whenever the hydroxy groups are on the 1 and 3 positions, that is meta to one another, this is ortho to one another, This is called as risorcinol, and whenever the hydroxy groups are para to one another, this is ardo, this is meta, and this is para. Right? This is ardo, and this is meta. The meta position, you will see a what hydroxy group here, and in the para position, you will see a hydroxy group here. This is called as phenol. All these are comprise the what you say positional or regioisomers, right? So this is the meaning of a positional or the regioisomers, right? And the other type of isomers are structural isomers are right. Metamers. In the case of metamers, the isomers have same functional groups, but different alkyl chains. They have the different alkyl chains. Say, for example, this molecule is called as, there's two ethyl groups here. This is diethyl. This is ether. Already we have discussed, right? And this is diethyl ether. It has an ethereal functional group with two ethyl groups. Ether with two ethyl groups. Similarly, if you see this molecule on the other hand, this is a methyl group and this is propyl group. This is called as methyl propyl ether. So the common point is that both of them have ether linkage, but the alkyl chain is here. It is a 2-carbon alkyl chain, 2 carbon. This is 1 carbon and this is 3 carbon. That is why such type of isomers are called as metamers. The metamers have same functional group. The functional group is ether, common, which is in both the cases, but different alkyl chains. Such type of isomers are called as metamers. And the other type of isomers are the tautomers. So this is a type of isomerism. This is the isomerism that arises due to migration of a proton. So there are different types of tautomers, not only the ketoenol tautomers, which is typically known for majority of the people. So simply tautomerism is a type of isomerism that arises due to migration of a proton. Proton means H plus, right? So this is whenever you take a hydrogen atom, this is hydrogen atom which has 1 electron. If it loses 1 electron, then it will become proton. 1 electron is lost. Similarly, if it gain 1 electron, then it will become negatively charged species. Then it is called as hydride ion. In tautomerism, this is the isomerism that arises due to migration of a proton, right? So one of the classical example is I'll write the acetone molecule like this. So this is acetone molecule, and it is the keto form. And if you observe the molecule here, there is migration of a S plus. The oxygen here is more electronegative. That is why it will pull the electrons towards its side. Whenever it will pull the electrons towards its side, it will gain a negative charge. And whenever the hydrogen, which is giving up its electrons here, it is directly, totally giving these electrons to the carbon atom and coming back here. Because whenever the two electrons are transferred onto the oxygen, it will gain the negative charge, and the positively charged species, that is H plus, will migrate here, and with the O minus, it will form a bond. And whenever such will happen, the valency of the carbon atom is 4. 1, 2, 3, 4. Two of the electrons are shifted here. Whenever you see any bond means it has two electrons. Two of the electrons are shifted here. That is why the carbon will gain positive charge. In order to nullify the positive charge, the two electrons between which present within the carbon atom as well as hydrogen are migrated here, and there is formation of a double bond. Right. This is the case, right? Now the carbon atom has valency 4. 1, 2, 3, 4. This carbon atom also has 1, 2, 3, 4, right? So this is nothing but this is also acetone molecule, but in enol form. En means a double bond. You have a double bond. OH means whole means OH, right? You will remove E here in en, and you will add whole, right? That is why it has become enol, right? Generally, any compound which has enolic structure, it is acidic in nature. Just simply remember, right? So this type of isomerism is called as keto-enol tautomerism. Not only that, we also have another type of tautomerism known as amido iminol tautomerism. You can see this amido iminol tautomerism. Just a second. Say, this is your amide. This is your amide, acetamide, or the amide form. In this case also there is migration of a proton, and imine means, you always remember, imine means carbon double bond N. So here if you see, it has two hydrogens. One of the hydrogen will be migrated here. Again, the oxygen is more electronegative, it will pull the electrons. H plus from here will transfer here, and there is formation of a double bond, right? This is imine, right? Carbon double bond nitrogen is imine. You'll remove the E because there is also O. This will become iminol. This is also acetamide only, but this is in iminol form. So acid amide form, and this is iminol form. Both the molecules are so this is which type of isomerism? Tautomerism. Amido iminol tautomerism. We call it as amido iminol tautomerism. We also have another type of tautomerism known as lactam-lactim tautomerism. I hope it is clear for you. I'll remove this. The next type of subcategory of tautomerism is lactam, lactim, tautomerism. This will be exhibited by barbiturates. So in competitive examinations, they will ask, barbiturates will exhibit dash type of isomerism, that is lactam, lactim, tautomerism. So before going to the details of the barbiturates, we should understand what is a lactam. Lactam means cyclic amide. Whenever your amide bond is in the form of a cyclic ring, then it is called as lactam. For example, this molecule is called as beta lactam, right? This is the alpha carbon atom adjacent to this, and this is the beta carbon atom. This is called as beta lactam. You see here, what we call the amide bond, C double bond ONH bond is in the form of a ring. That is why it is called as beta lactam. Similarly, we also have extended versions like this. This is alpha adjacent to the functional group beta and gamma lactam. Majority of the people will be in a perception that lactam means only beta lactam. It is not like that. Lactam may be of any size. The simple point is it will start from a 3-membered ring. So this is your alpha lactam, because this is the alpha carbon atom. This is alpha lactam. Am represents amide, right, in the cyclic structure, right? So like this, the lactam may be of any size. Okay, it is not like a 4-membered ring, which is typically seen in penicillins. It may be of any size. So coming to specifically, we are much interested in what we say, the tautomerism that is exhibited by barbiturates. So barbiturates are the 6-membered rings. So if you see the structure of the barbiturate, I'll write it more clearly. Here you see, these are the active hydrogens. So this is the structure of barbiturate. This is in lactam form. If you see here, it is a cyclic amide. If you see this portion, it is a cyclic amide. This is cyclic amide, right? So this is barbiturate in lactam form. And what will happen is the protons here will migrate on the oxygen atom, right? And whenever protons will migrate, what will happen? There will be transfer of this particular double bond here. I mean, this bond onto this, and we'll get a structure something like this. Right? So this is nothing but the lactam form. There you have immunol, or you can also call this part of the molecule, if you observe, it is like keto, and this is enol, right? Double bond OH. This is C double bond N OH. Immunol, and this is like enol. So if you observe, both immunol form is there as well as enol form is there, but there is 2 times immunol form. That is why this type of tautomerism is typically called as lactam tautomerism. Sometimes in the competitive examination, they will give barbiturates will exhibit keto-enol tautomerism as well as lactam tautomerism. If you see here, it is a keto group, and this is a enol, and this is a amide bond, and this is immunol bond, right? So whenever what we say, if they ask, if they give an answer, so multiple choice question where there is keto-enol tautomerism, lactam-lactam tautomerism, and other type of isomerism, you need to give first priority to lactam-lactam tautomerism. Sometimes what they will do is within the same options, they will give both keto-enol as well as lactam-lactam. Then you need to consider both the option which contain both these terms, keto-enol as well as the lactam-lactam tautomerism. I hope you have got a clear-cut idea about structural isomerism. It is called as structural isomerism because they have the same molecular formula but different structures, right? Here the structure is different in all the cases. In the case, in the initial example, what we have discussed is ethanol as well as dimethyl ether. Both these are having different structures, right? Similarly, the chain isomers, they have different structures. So simply structural isomers, they have the same molecular formula, but they have different structures. That is why they are also called as structural isomers. Are also called as they are also called as constitutional isomers because they have a different constitution. Constitution in the sense, so for example, this is butane. This is 2-methyl propane, right? This is having one type of constitution, and this is having one type of constitution. This is having one type of structure. This is having another type of structure. So the structure is different, or the constitution of that particular molecule is different. Then they are called as structural isomers or the constitutional isomers. So basically, it is important. I will summarize the things. Isomers are the one which have the same molecular formula but different arrangement of atoms or the groups. And one type of isomers are structural isomers. They are also called as constitutional isomers because they have different structure or the constitution. That is why they are called as a structural or the constitutional isomers. Not only that, there are different types of structural isomers. One type of structural isomers are chain isomers, which have different alkyl chains. We have seen the example of just now butane as well as 2-methyl propane. Not only that, we have also observed another type of isomers known as functional group isomers or the functional isomers, where they have same molecular formula but different what you say functional groups. One of the classical example what we have seen is ethyl alcohol as well as the dimethyl ether. Not only that, we also have regioisomers or the positional isomers where they have the same functional groups, but the position of the functional groups is different. We have discussed the examples like propanol, 1-propanol, as well as 2-propanol. Not only that, we have also explored another example containing the aromatic ring structures like catechol, resorcinol, and phenol, which have hydroxy groups in 1, 2, 1, 3, as well as the 1, 4 position, or the ortho, meta, or the para positions to one another. And other type of isomerism is metamerism. In metamerism, metamers have same functional group but different alkyl chains. One example we explored is diethyl ether as well as methyl propyl ether. Diethyl ether has 2 ethyl groups, whereas methyl propyl ether has 2 different alkyl groups, right? Such type of isomers or the structural isomers are called as metamers. And the last and final type of isomers are tautomers or the tautomerism. The tautomerism is a concept that will arises only when a molecule has the ability to transfer a proton within the molecule. That is why it will arises due to migration of a proton in the molecule. One type of tautomerism is keto-enol tautomerism, which is typically seen in aldehydes as well as the ketone molecules, where there is existing of keto form as well as the enol form. Not only that, the compounds containing the amide linkage will also exhibit this type of isomerism, wherein there is also migration of a proton to form amide. Amide will be converted into immunol form, C double bond NOH, where the carbon bear the hydroxyl functionality. Not only that, the amide will be in the form of a cyclic structure known as lactam. The compounds which have the lactam will exhibit lactam-lactam tautomerism. The classical example for this is barbiturates. I hope you have understood and got better knowledge about structural isomerism. We will meet further in another session or another topic. Thank you so much for watching, and let's hope our videos will help you a lot for better understand the concept of organic, medicinal, as well as natural product chemistry. Thank you.